Hello, welcome to this video, the second video in our projectile motion set of notes, where we're going to see how things get simplified when the launch when the launch height is 0. Launching from the ground, we can use familiar physics formulas to help us calculate 3 calculations. So, when the object is launched from the ground, we get nice simplified calculations. Let's say we still know the angle, the launch angle theta. We still know the initial velocity, and now we know that h is equal to 0 in our formulas. When it comes to the gravitational constant, 32 feet per second squared if you're in feet, or 9.8 meters per second squared if you're in the metric system. Okay, nice easy formulas. I won't go through the business of showing you why these formulas are what they are, but the maximum height can be found by taking the initial speed times the sine of the angle theta. That whole quantity gets squared in the numerator and then divided by twice the gravitational constant. How long the object is in the air, the flight time, can be calculated by taking double the initial velocity times the sine of theta divided by the gravitational constant. And then finally the range, the horizontal distance traveled by the object, we use capital R for that. That can be found by taking the speed squared times the sine of double the angle, all divided by the gravitational constant. And remember now, air resistance is neglected. So be free to use these formulas if it is the case that you are launched from the ground. Okay. All right, great. So here's an example. A golf ball is hit from the ground with a 35 meters per second velocity, and at an angle of 55 degrees, and the ground is level. So let's calculate the 3 guys. This first question is asking about the flight time. So we have the formula. We're just going to plug in double the 35 times the sine of 55 degrees, all divided by, since we're in meters, we're in the metric system, so G is 9.8. And it's okay to use a calculator. It's fine at this point with these kinds of questions. If you show me your inner workings before you plug into the calculator, you can get full credit. And so then the second question asks, well, what's the maximum height that the golf ball reaches? And we have a formula for that. Just take the speed times the sine of the angle, square that product, and then divide by twice the gravitational constant. 35 times the sine of 55. That whole product gets squared, and we double the 9.8. About 41.9 or 42 meters high is how high the ball reaches. And then finally, the horizontal range, the distance traveled horizontally by the ball, is found by this formula. And we can find out then the question, how far is from the launching point does the ball hit the ground? By taking 35 squared, taking the sine of 110, and dividing that product by 9.8. We get a range of 117.46 meters. Okay, almost, it's more than 300 feet. Okay, just plug right in. Nothing wrong with that at all. If it so happens that you're launching from the ground. Okay, if you're not launching from the ground, then you can't use these formulas at all. All right, one more question. We have a classic question again, the baseball problem, where this time we don't have the same kind of given information that we're used to. Citizens Bank Park is where the Philadelphia Phillies play, and there's a fence that's 330 feet away from home plate, and the batter's going to stand there. That fence is 13 feet high. The batter's going to stand there and hit the ball 3 feet off the ground. Ryan Howard happens to be the batter. This is an older example. He's nice and retired now, but had quite a run with the Phillies. Won a World Series. Anyway, we know the initial height, but when it comes to velocity, we don't know the initial speed. It's kind of strange. We know it in pieces. We know the horizontal velocity, and we know the upward velocity. We don't know the launch angle. Okay, and the question is, okay, well, there's that fence that's 13 feet high, 330 feet away. Will the ball clear the fence? How many feet? By how many feet does the ball clear the fence? Okay, and so since we Since we don't have theta, we can't use that formula. We have to go back to the original formulas where we have the acceleration, velocity, and position function just built from integrating. Okay, and g for us is going to be 32. So these are copied just from the previous video. First principles, I like to call them, using physics to get the acceleration vector, Newton's law of motion, and the fact that F equals ma, and also the fact that gravity is working downward, minus mg in the j direction. Those together give us the fact that acceleration vector is minus g in the j direction, so negative 32 in the j direction, but 0 in the I direction. The velocity vector is that minus 32t in the j direction, but then plus the initial velocity. And for this particular problem, it's broken down where we have the initial velocity is 66 in the horizontal and 84 in the vertical. G is 32, of course. These are all coming out of order. Sorry about that. So we have, then we can put these together, i's with i's, j's with j's. We can have 66i and then minus 32t and 84 to give you the velocity vector. Integrate that velocity, you'll get position minus 1/2 of 32t squared in the j. Then the v naught is times t. And then the initial position, it's not horizontally forward or backward. The origin is where the hit point is, the launch point, and it's 3 feet off the ground. So 0, 3 is your initial position. So you can say then that as far as I goes, you have 66t on I. As far as j goes, minus 16t squared, 84t, and 3 in the j direction. You have everything you need. This is about the this is about the position vector, and so we have to find out how long does it take the ball to fly 330 feet horizontally. Take the horizontal component, take the I component of your position vector, set it equal to 330, and you'll end up with a nice value of t equals 5 seconds. 5 seconds later, the ball is on that fence. How far above that fence is it? That's the question. So we can take this time t and figure out what the vertical height of the ball is 5 seconds after launch by plugging into the vertical part of position. Negative 16 times 5 squared plus 84 times 5 plus 3. Negative 16 times 25 is a negative 400. And then 84 times 5 is a 420. And then a 3. So 23 feet off the ground. 5 seconds after it's hit, the ball is 23 feet off the ground. The fence is 13 feet. So you're going to clear it by 10 feet. Okay, classic projectile question. Where you don't have that information given, you have to go from those basic principles of the vectors A, V, and R. Alright, well this ends the video about projectile motion, about the whole, it's actually finished off the whole series about projectile motion, just 2 videos. And my name is Nakia Rimmer, here to help you through this journey, multivariable calculus. And please like and subscribe or comment down below. Reach out to me if you have any questions. And I'll see you in the next video. Bye-bye.